All right. Okay, so we're looking at number 18 today. We are going to be solving absolute value equations and inequalities. We're going to cover them both. And today is the 6th. Absolute value equations and inequalities. All right, so somebody tell me what is absolute value before we even get any further. Riley? Exactly. The distance the number is from 0. So does it matter which direction from 0? Like the absolute value of 3 is what? 3. The absolute value of negative 3 is 3. Okay, so because distance can't be negative. I can drive to Nashville and drive 90 miles, and even if I put my car in reverse and drive backwards all the way back home, it's not going to be a negative 90 miles. It's still just 90 more miles because it's distance. Distance is not negative. The only way I can get that negative answer is if the negative was on the outside. And then that's just saying the opposite of the absolute value of 3. Okay. All right, so let's look first at the equations. And let's just say we have our absolute value bars just around the x for right now. And this was my problem. The absolute value of x plus 5 equals 11. So we're going to just solve it like normal. What would we do first to this equation to isolate that x? Ann Abbott? Well, I might actually do those absolute value bars last. So what else am I going to have to get rid of? Paisley? Yeah, I'm going to subtract 5 from each side. So now I'm down to the absolute value of x equals 6. So then you got to think, okay, now I've got to look at what's the bars about. So what numbers could be the value of x? Ann Emmett? Yes, negative 6 and positive 6. So for my answer, I would actually write that x equals 6 or that x equals negative 6. You have both options as your answer. Okay, so now if you have one like this on homework, you don't have to write the x equals 6 or that or all of that. You can just put 6 and negative 6. They are both valid answers for this equation. It just depends on the situation which answer you would need. Okay. Same thing. If I had 3 times the absolute value of n equals 15. So take care of isolating first. So how do I get rid of the 3? Divide by 3. So I have the absolute value of n equals 5. So what are my two values? Yes, negative 5 and 5, because both would give you 5 as the absolute value. All right, making sense so far? Okay. All right. Let's do, you do this one. absolute value of r minus 2 equals negative 1. All right, Eli, what did you do with this one? All right, added 2 to both sides. So we have the absolute value of r equals what? 1. All right, so then what's my two answers? Yes, 1 and negative 1. How many got 1 and negative 1? Okay, good, good. All right, let me give you one more to try. Do 4 equals 3 times the absolute value of w minus 2. See what you can do with that one. All right, Trinity, what'd you do with this one?
I added the 2.
All right, she added the 2 to both sides first. All right. All right, so 6 equals 3 times the absolute value of w.
And then I divide by 3.
All right.
And measures 2.
Okay, so 2 equals the absolute value of w. So what are my two answers?
2 and negative 2.
Yes. So 2 and negative 2. How many got 2 and negative 2? Okay. All right. Good. Good. All right. Now, let's look. So far, only the variable has been in your absolute value bar. So let's look at it if you have this whole section, this half of the equation is in the absolute value bars. Let me put it right here. So let's say I've got, well, actually I'm going to turn to the back so I have more room. I don't want to crowd it up too bad. Let's see, so this is 5. Let's do the absolute value of 2p plus 5. Close your bars. All that's in your absolute value bars equals 11. Now, when you have this, you actually have two equations to solve. So we're going to set it up as 2p plus 5 equals 11, and 2p plus 5 equals negative 11. And we're going to work it both ways. That's where we're going to get our two possible answers from. Okay? All right, so go ahead and work each side.
I now want to solve some inequalities that also have
got it? Okay. Kane, what did you do for the first equation?
I subtracted 5 and I got 2p equals 6. And then I divided by 2. I got p equals 3.
Good. All right. Mass Brazier, what about this second one? Okay. -8. Okay, so what that means is our two solutions are 3 and -8. So that tells me I can plug either number in and it will work. So if we plugged in the 3, what is 2 times 3? 6. What is 6 plus 5? 11. All right, if I plug in the -8, what's 2 times -8? -16. And -16 plus 5 is -11, but the absolute value of -11 is 11. Okay, so when the whole problem, the workings there in the bars, you're going to have to do it both ways. Okay, that's how you get those two separate answers. All right, let's try this one. So I've got C minus 2 in the bars equals 6. So what's going to be my setup? So C minus 2 equals 6, and C minus 2 equals -6. All right, so work those real quick. Find your two answers. All right, Andy Jane, what about the first equation here? All right, adding 2. So that gave you C equals 8. All right. Let's see. Savannah, what about the second equation? And that gave you C equals -4. And we could plug them both in. 8 minus 2 is 6. -4 minus 2 is -6, which gives you 6. Okay, so you can check your answers. You'll know instantly if you're right or not. All right, now, what if I did this? -3 equals C plus 4. Think about that. Is there a problem? Yes. What's the problem?
The solution should be negative.
Exactly. The solution cannot be negative. When the whole thing here is in the bars, you can't take the absolute value of anything and get negative, but you'll have those every once in a while. They'll throw those in. So if you see that, you simply write no solution. Because that is not a possibility for us. We cannot work that through and get true answers. I mean, you could try it. We could have set it up with, if we subtracted 4, you would have got -7 equals C, but you can't, if you plug that in, the absolute value of -7 plus 4 is not going to be -3. Yes, Anne?
If you put like the negative sign outside of the absolute,
Then that would be okay. Yeah, we could work through with that. Yeah, that would be like having a -1 outside there. So we could do that. Okay. All right, now let's look at if we have, let's put some inequalities in there. So let's say I've got, let's do the absolute value of x minus 3 greater than or equal to 4. All right, so when we have it with an inequality symbol, just like with an equation we had 2 equations to work, with an inequality you got 2 inequalities to work. Well, we said the other day, when you have 2 inequalities, what do you really have? What's it called? A what? Well, no, like we did, compound. When we did the and or ors, those were compound inequalities because you were working with 2 inequalities together. Same idea. Okay? So if I have this, then I not only, whoops, do I want the bar? No, I don't want the bar anymore. I have the inequality that they gave us. Just ignore that little squiggle. I didn't mean to write that. So I have the x minus 3 greater than or equal to 4, and just like with the equation, we rewrote it with a negative answer. We're going to do that with the inequality, but we are also going to flip the sign. Okay. And this is an or. So we keep it, and then we rewrite it, and we flip it, and we go opposite of whatever the answer was. Okay. And then we work both sides. So what are we going to do over here on the left? We're going to add 3, and x is going to be greater than or equal to 7. All right, if we work this side, we're adding 3. X is going to be less than or equal to -1. Okay, and now I'm going to graph this one with you. We're not going to graph a lot today. I'll just do it above here so I have room. So think about it. It says x is greater than or equal to 7. So where are the numbers greater than or equal to 7? To the left or the right? They're to the right, correct? That's where the number's bigger, like 8, 9, all of that. All right, what about x is less than or equal to -1? Where are those numbers? Yeah, they're to the left. All right, so I didn't leave a lot of room, so I'm just going to squeeze it in. Okay. So what kind of, on x greater than or equal to 7, am I open or closed? Yeah, closed. And we said it's going to the right. And x is less than or equal to -1, open or closed? Closed. And we're going to the left. Okay. So let's pick out a number. Let's just use the -2. If I plugged in -2, what is -2 minus 3? -5. What's the absolute value of -5? 5. 5 is greater than or equal to 4, right? So that works. All right, try one over here. If I picked up the 8, what is 8 minus 3? 5. Absolute value of 5 is 5. 5 is greater than or equal to 4. So you should be able to try something from each one. But remember, don't try the one that you start on. Okay? Try the others. Plug in, and it should work. And then you'll know you got that right. Okay? All right. Let's do another one. Let's do, sorry. Let's do x minus 5, the absolute value of x minus 5, less than or equal to 2. All right, see if you can set that up. everybody ready? Yes, no? Okay, let's see. Brianna, how did you set up, what was your first inequality?
Audit x minus 5 is less than or equal to 2.
Okay, all right. Okay,
X minus 5 is greater than or equal to -2.
good. How many got it set up correctly? Good. Okay, awesome. All right, Brianna, go ahead with this first one and solve that for me.
So we would add 2.
You would add how much?
2. Oh, 5.
5, yeah. So we got x less than or equal to 7. Okay. All right. William, what about on this side? What are we going to do first? And 5. So I got x is greater than or equal to 3. All right. How many got those two? Okay, good. Do we need to graph that one, or are y'all okay on that? I feel like you're okay with the graphing at this point. I'm just trying to make sure you can solve them. Let's see if there was another. Okay, that's all right. Let's do let's look at this one. I've got k minus 3 in absolute value bar, sorry, and then plus 7 greater than 8. Okay. All right, so before we set up the two different ones, let's simplify it a little bit. Let's take care of this 7 because it's not in the bars, so let's go ahead and take care of it. So let's get it over to the other side. So how can I move that 7? Yeah. So I really have absolute value of k minus 3 greater than 1. Now you work with it and separate. Okay. All right, see what you can do with that. All right, Kaylee, what do you got here? Good, good. All right. Let's see. Brandon, go ahead and solve the first one for me.
Added 3 to both sides.
Okay. So that gave you k is greater than All right. And then, let's see, Eli, what about on the right side? So you got K is less than 2. Okay. All right, let's put in, because these have been pretty much just one-step inequalities. They've not been too complicated. Let's see if we can't step it up a notch. Let's do absolute value of 2x minus 4. Let's make that a negative 2x minus 4 in absolute value bars less than 5. Or let's make it 6 so we don't get decimals. Let's just keep it. Let's make it even. Let's say 6. All right, so what's my two inequalities going to be? Negative 2x minus 4 less than 6. And then my other would be yes. All right. Go through solving those. All right, Grace, what'd you do with the first one?
First I added 0 to both sides.
Okay.
I got negative 2x is less than 10. And then I divided both sides by negative 2. And I got x is less than negative 5.
You sure?
Oh, I didn't flip the sign.
I got to flip the sign. So x is greater than negative 5. How many people remember to flip their sign? Okay, good. I didn't say anything because I just wanted to see if you would. All right. Let's see. Christopher, what about the second half?
Add 4 to both sides. So then you have negative x is greater than negative 2. You're going to divide both sides by negative 2, so you're going to flip the sign. So x is less than negative 1. It's less than 1.
Is less than 1. All right, so x is greater than negative 5 and x is less than 1. So now think about that. What numbers are greater than negative 5? Like negative 4, negative 3, negative 2, negative 1. What numbers are less than 1? 0, negative 1, negative 2. So is this going to be an OR? No, this one would be an AND when we graph it out. So there's not a definite. So some of these you just got to work through. No, I didn't write OR. We didn't. I didn't double check this one. Maybe we should. Oh, we wrote because whoever we did it, you said OR and I went with it. But let's think about it. X is less than or equal to 7. What numbers are less than 7? Yeah, 6, 5, 4, 3, 2, 1. X is greater than or equal to 3. What numbers are greater? Oh, yeah. So is this going to be an OR? It's going to be an AND. But see, I like when we do stuff like that because then it's like it starts to make sense of why we put and or. So we got to kind of think about that. Okay. All right, I'm going to stop there with your notes. In your Google Classroom, there is, I think it's like a 10 or 13 minute, I can't remember exactly, but you have time to watch it before you leave. And then your homework is only 6 problems today, and you don't have to graph on the homework, you're just solving them. Okay? So Google Classroom, video, and then work on your homework if you got time.